Today, a staggering 88% of modern corporate organizations have fully integrated artificial intelligence into their daily operational workflows. Lawyers, doctors, and financial analysts are running critical data through these systems, expecting they will behave with the consistency of a calculator. Yet, in 2024, businesses lost $67.4 billion to AI-generated hallucinations. Legal researcher Damien Charlaton's database now documents 1,769 court cases derailed by fake AI citations, contributing to over $145,000 in sanctions issued in early 2026. The financial sector faces a similar silent crisis, exemplified by a robo-advisor hallucination that affected nearly 3,000 client portfolios and cost $3.2 million to fix. These losses are the direct price of a specific operational friction. The machine's output rarely matches the user's expectation of accuracy. In traditional computing, when a machine lacks data, it typically delivers an error code or a blank screen. It admits the limit of its knowledge. Generative AI never hesitates. It produces no error codes when it lacks a factual answer. This exploits a specific human tendency. We are wired to trust information when it is delivered with an authoritative, confident tone. This intersection, a machine that refuses to admit ignorance and a user who trusts confidence, creates the environment where hallucinations go undetected. Large language models are often treated as digital libraries, retrieving stored facts. However, their internal structure is different. They are prediction engines. They generate text by statistically guessing the most probable next word based on patterns in their training data. When the engine hits a gap in its training data, it fills the void by generating a plausible-sounding sequence. It optimizes for the most likely word rather than for the truth. Two independent mathematical proofs have demonstrated that hallucination is a permanent, provable limitation of this architecture. It is an inescapable part of how the systems predict text. Since these errors are a mathematical certainty, companies cannot wait for a software patch to solve the problem. MIT researchers found that AI models use more absolute language, words like definitely and certainly, when they are generating incorrect information. The wronger the AI is, the more certain it sounds. In the race to build more capable tools, developers are trading away calibration, the model's ability to know its own limits, in exchange for higher scores on knowledge tests. The latest AA Omniscience benchmarks illustrate this trend. GPT 5.5 and Gemini 3 Pro rank high in raw accuracy, but when they don't know an answer, they fabricate one 86 and 88% of the time. Anthropic's Claude Fable 5 follows the same pattern. It reached a record accuracy of 61%, but its hallucination rate rose to 54.9%. The model is guessing more aggressively to achieve its higher score. These machines are more knowledgeable than their predecessors, but they are also less aware of their own boundaries, making them unpredictable in a high-stakes corporate environment. Relying on a single AI platform to verify a high-stakes business decision is an invitation for financial or legal error. Rather than an all-knowing oracle, businesses must manage AI like a capable but unreliable employee. You cannot use a single model to check its own work. If you ask a system that is mathematically prone to people-pleasing to review its own errors, it will likely confirm its original fabrication. Integrating AI into a business requires a shift away from blind trust towards systems built on verification. Multi-model validation provides a defense against mathematically guaranteed hallucinations. This process involves pitting different frontier models against one another. You run a single query through GPT, Claude, Gemini, and Grok simultaneously. Because these models have different architectures, a confident lie from one is rarely supported. Their disagreement pinpoints exactly where the machine is guessing. This setup converts a hidden hallucination into a visible data point that a human can review. In a business environment where AI is integrated at scale, the disagreement between models is the mechanism that identifies errors before they turn into a multi-million-dollar disaster.